Okay, so a while back I uploaded a short talking about how ludicrous prices for Raspberry Pis have gotten, partly due to the silicon shortage and partly due just because people are scalping these things like crazy. I swear, first it was the GPUs and now it's Raspberry Pis. They'll scalp anything these days. So what that got me to thinking was, obviously people like me who are going through a college tech program. In my case, it was computer engineering, but computer science, electrical engineering, all these things kind of incorporate microcontrollers and other little tech things into their curriculum. So I was thinking for potential students who can't afford to pay these scalped prices for these Raspberry Pis, what are some alternatives? And that actually brings us to the subject of today's video. That's this little guy. This is the Raspberry Pi Pico. It's only a couple years old, I believe. It's the first microcontroller released actually by the Raspberry Pi Foundation. And we're going to be talking a little bit about it today. But first, I think it's really important to kind of distinguish what the difference is between a microcomputer and a microcontroller. So I guess we'll start out with the microcomputer. Microcomputers are things like the Raspberry Pis. They have, a CPU. In this case, I believe on the 4B, this is a quad core. You got your USB ports on the side, gigabit Ethernet. You got your Gpio pins, obviously. We have USB-C for power, 2 mini HDMIs, headphone jack, and then these little connectors right here are pretty cool. They are ribbon cable connectors, and they allow you to connect little LCD screens to the Raspberry Pi. It's really neat. And then you got your CPU. I believe this is RAM right here. And one thing that's really important on both of these, you can see this. The 0 is just a more cut down version of the 4B. It has a little bit less I/O. But it's still overall the same thing functionally. But what you'll notice on both of these is that they have SD card slots for mini SD cards. Now these are important because what these do is they allow us to boot an operating system onto these things. In this case, this one has Raspberry Pi OS, and this one has the operating system for Pi-hole. That's what I was using this thing for previously. Was I made a Pi-hole to filter out ads on my network. So they have, pretty high specs for single board computers, and they can run an operating system. So that brings us to a microcontroller. How is that different? So for a microcontroller, the specs are much more cut down. The CPU, instead of running at thousands of clock cycles, only runs at a few hundred. It is actually a dual-core ARM chip. I forget the name of the particular chip, but it's not really important right now. And what you'll notice on the microcontroller is it has the pins on the side that you can mount male or female connectors to, but it only has a single micro USB port. It doesn't have HDMI or USB-A or the ribbon cables. It doesn't really have much I/O and ways to interact with them. And that's because it doesn't really allow for a lot of different peripherals. The microcontroller actually does not run an operating system. In this case, this particular thing, this particular microcontroller can only run one program at a time. So rather than an actual operating system, what you do is you use the micro USB port to load your program onto it, and then from there it will run the program so long as it has power. And that's actually stored on the ROM, which I believe is right here, this little black IC right there. So yeah, that's the main differences between microcomputers and microcontrollers. So what I thought I would do today is kind of give you a little demo on how to use the Raspberry Pi Pico, because what I think the important thing to realize is that for most people, you probably don't need a full-fat Raspberry Pi to run an OS on and connect to a monitor, keyboard and mouse, all that. You could just use your laptop to program a microcontroller like this and run programs that way, and you can wire it the same as, in fact I think this might actually have a few more pins on it than the full-size Raspberry Pi. Not sure about that, I'll have to go back and check. But in most cases you don't need the full functionality of this, and just running programs on something like this that's a little bit smaller, a little bit more simple, and especially cheaper, is going to be good enough. And that's the thing with the price, is that, you know, at the time of this video, with these inflated prices, the 4B is going between $150 and $200 on eBay, and that's just for the board. That doesn't even include some of these fancy kits with all these accessories. With the Zero, it's about $40 when it used to be $5. It's insane how inflated these prices are. However, the Raspberry Pi Pico is actually only $5. I think it retails for $4. It's $5 where I got it. It fluctuates a little bit depending on where you got, but it's so cheap compared to some of these other things. And for most people, this is going to be enough to give you the full functionality. So that's why I thought that this would be a very good alternative to some of these things that are much more than students should be spending on a single board computer. So what I think would be interesting now is I'm going to pull out some of the breadboard stuff, and I'm going to show you how to program this thing. It's actually pretty simple. One thing about this that I thought was interesting to note was you can see on the back all of the GPIO pins are clearly labeled, and it tells you which one each is. However, this is the side that's normally going to be sitting face down on the board. So it's this side that you'd ordinarily be looking up to see what the pins are, but there are no numbers on this side, so I don't really understand that. I would hope that in future editions they can silkscreen the numbers on these pins. That would be so extremely helpful. But yeah, so real quick, I mentioned we have the micro USB port, and then we have our CPU in the middle right here. I believe this black IC right here or right here, one of these is ROM. This button right here, that is actually for putting the Pico into programming mode. And that's actually how you're going to load your program onto the Pico, and it will be stored in the ROM. I believe this metallic silver looking package right here, I believe that's a clock. So this does have a onboard clock that's actually very useful for running certain programs. So yeah, pretty cool little device for, you know, $5 for the price of a McDonald's meal. I think it's a pretty great little thing. So let's go back to getting it prototyped and programmed. Okay, I was originally going to like breadboard all this out, but I have all my breadboard gear put away, so I wasn't going to bother. But what I did was I installed Thonny. This was actually really easy to do on a Windows machine. So I installed Thonny, wrote a few lines of code. Basically, I'm just trying to blink the onboard LED. And I ran the code, and as we can see, there we go. You can see the onboard LED, it blinks. I think it updates on 1 second. Just a simple loop, but as you can see, it's very simple. If you want to, basically this USB port allows us to interact with it. All we need, it shows up as a USB storage device, and yeah, that's pretty much it. I think one thing to note is that if you want to make sure the program runs persistently without the use of Thonny, all you have to do is name it main main.py.python. So there you go. But yeah, it's a pretty simple little device to use, really fun. You can solder male or female leads on here to connect it to a breadboard and use pinner wires. It's a great little thing for learning, I think, and it's $5, guys. It's so cheap, and it's great. You get a lot of power. A 2-core ARM processor, probably a little bit overkill. You could utilize 2 threads if you want to come up with something a little bit more complex, but overall, you're getting a great value for your money, I think, and especially with having to pay, you know, $150 or $200 for this scalped thing. Yeah, I think it's a great idea. So this was just a little overview of the Raspberry Pi Pico, and I wanted to explain the difference between a microcomputer and a microcontroller. So let me know what you guys think down below. Obviously, I hope that the scalping will stop at some point, but I don't know. But until then, I think that this is a fantastic way to get around that, and to get some learning in for embedded systems, because they're a lot of fun. So yeah, if you guys liked the video, please leave a like down below. Be sure to subscribe, and we'll see you next time.